All right, welcome to the stream. Let's get started. So what we're going to do today is I have this library called juniper-from-schema, which is Juniper, a different library that I didn't make, is a GraphQL library for Rust. Basically, it allows you to, so if you open the book, it's a pretty good resource. It allows you to basically define a GraphQL schema in Rust, and then how to resolve the queries and like actually run them, right? In sort of a type-safe way. So I think the quick start is like a good example. So you write like normal Rust code, and then they have special like derive macros or special traits that you can implement that sort of tell you how this how this Rust type maps to like into the GraphQL world. And then so this is like the main macro that you use, like GraphQL object. You have your type, and then you specify each field. And then they have stuff for like evaluating queries, and they can call your fields you define it through this macro and so on. So the main thing in like GraphQL that's missing from this is that you don't actually get a GraphQL schema. At least not like a text file that you can open and read. Instead you get all this Rust code. So what I made is it's called juniper-from-schema. If we open the documentation, basically it allows you to write a like normal GraphQL schema file like this, and then it gives you this macro called GraphQL schema from file, which takes the path to the file, and then at compile time it will read the file and then generate all the corresponding like Juniper sort of boilerplate almost for your GraphQL schema, and then it gives you these special traits that you then have to implement that then say how to resolve each field. And so that means that you can sort of get the best of both worlds. You can get the type safety from having your schema implemented in Rust, and you can write an actual schema that you can then share with whatever clients you might be having. So for example, if at work you're a backend engineer and you maintain some API, and then you can share and collaborate on this schema with your mobile clients or whoever that might be, and then at the same time having that implemented in Rust. So it is almost feature complete. The main thing that we're sort of missing is that we don't have default arguments yet. I did a bit of a spike on that over Christmas, and it's turned out it's actually pretty difficult. So I don't think that this is what we're going to be tackling today. Instead, we're going to fix a small bug with the query trail feature. So what that is let's see if I can find an example. Query trail. So if you imagine that you have a, is there a better example than this? Yeah, so if you imagine that a common sort of issue in web development and with using databases in general is that something called the n+1 query problem. So that is that imagine you have like a list of posts. Maybe you're making a blog and you show some page that shows all your posts, and for each post it shows the number of comments that post has. That will give you, if you just do it the naive way where you say give me all the posts, and then in some loop you say now give me the number of comments for this post, that might, if implemented without a lot of care, give you what's called an n+1 query bug, which means that you do one query to fetch all the posts, and then for each like n posts, you do another query to load the number of comments. And that means that the number of queries you do will just very quickly grow. So that's not something that you want. And this is, if you don't do it carefully, this is very easy to implement in GraphQL because all your queries are sort of arbitrarily nested, and it's a bit difficult to know ahead of time how much you have to like preload or eager load, or how you have to construct your queries in order to have the least overhead as possible. So here's an example of, or rather, the way that they deal with that in Juniper. If we open their documentation, is they have something called a lookahead, which is on the executor, which is like the object that evaluates your queries. You can say, give me a lookahead. You get back a lookahead selection that implements this lookahead methods. And lookahead methods basically allows you to say, is this particular field selected? So imagine that going with our posts and comment example from before, if you have a lookahead for the posts, then you can say, are you also loading the comments? And if you're loading the comments, are you loading like the text of the comment and the author and so on? So you can sort of introspect the query ahead of time before you actually get to evaluating it, and then make smart decisions based on that. However, the key detail here is that these names, which is sort of the keys that you look up and check for in your query, these are all strings, so they're not checked at compile time. So what we do in juniper-from-schema is we have this type that we call a query trail, which is basically a lookahead or a wrapper around the lookahead, but it is type safe. So here you can see to evaluate this create post field here, it's a mutation. I get along with the executor and the input that I get from the query, I also get this query trail value. And it has two sort of generic arguments. It has a post, which in this case is just the return type of the field. And it also has a walked. So a walked means that we know that the user is actually asking for the post. Now this is a bit contrived because it's the root in this query, so why wouldn't you ask for the post? But we would then be able to, on this query trail, we would be able to say, okay, are they also asking for, like a post has a title. So we'd be able to say, are they also asking for the title? And if it has like more sort of nested data inside it, we're able to traverse that in sort of a type-safe way, right? So I think that's going to be clear later. So all these query trails, each of these like variants and what methods they have are generated at compile time. And the reason that we can do that, and the reason that Juniper can't, is because we know the whole schema up front, right? So Juniper doesn't know the schema up front because you can call the macro whenever you want, so they can't exactly generate all these methods at compile time. But we can do this in our case. So what I realized that we're missing is that if you have a union type or an interface, we don't generate all the correct methods for this for the query trail when you're using like a search result. So in this case, we would have to know that on this particular search result query trail, since it is either an article or a tweet, we should be able to call these methods. How exactly that's going to work for union types, I'm not sure. But in the case of like interfaces, we should just be able to call the methods that are defined on the interface, right? Since unions are basically like either, so it's either this or that, I'm not quite sure how we're going to do that, but I think we'll start with the interfaces and see where that gets us, and maybe we'll actually learn how to do it. So for those of you following along, on my GitHub page, I have the repo here, juniper-from-schema, and the issue that we're fixing today is this guy, query trail methods not generated for interfaces and unions. So I have already set up a branch, and I have run the tests, and they do in fact all pass. Most of the tests, since this library sort of is a procedural macro, most of the tests is just declare a schema, declare the corresponding ROS code, and then verify that it actually compiles. I do have some end-to-end tests that actually set up a Juniper sort of instance and allows us to actually test that sort of end-to-end wise it works, but I don't test Juniper-from-schema exhaustively here. I have a bunch of like integration tests that actually tests everything sort of exhaustively. But this is just that it actually all compiles, which it does. And in case you didn't catch it, I'm in Vim, so I hit leader T, and that compiles the code. And if we put it here, let me just make sure that it actually fails. It doesn't. I believe that is because we don't actually run the tests. Cargo check tests. So like these are sort of this is a Vim plugin that I made myself years ago called Spectacular that lets you like define for each like a list of languages, call this command when you like hit a certain key combination. So you can sort of use that to run tests basically. And all I do in Rust is just check that it actually compiles. And then I have a separate command to actually like run the tests. So we see that we do get a failure. It just complains that that thing is not in scope. And if we delete it, it should pass. Hey, I see we got a new follower, X message. Thank you for the follow. And if you have any questions at any point, just post in the chat and I'll address them. So the very first thing that I think we need is to actually having a test that verifies that this bug exists. So since this is a compiled on macro, I don't want to, like I need to define this query type multiple times, so each test is sort of scoped to its own module. And then they all use super, which just gives me this context type that I need for all the tests. And this is just some Juniper thing that it defines. So let's say mod query trail methods for interfaces. And it's been a while since I've been in this code base, so I'm mostly going to copy and paste between existing code. So let's try to implement this example that we had before of a post, which then has comments, and then we can sort of change that into an interface, and then we should see that the code goes from compiling to not compiling anymore. So let's say posts, it doesn't take any arguments, and if I can use Vim correctly, that'd be nice. And it returns a list of posts. And in case you're not familiar with GraphQL, these exclamation marks basically means that the list itself is not optional, and that each post inside it is not optional. So this means that it's basically in Rust terms, it's this. Whereas if we do this, it would be like option post. So by default, if you don't specify anything else, then post, then the values are optional in GraphQL. Why that is, I'm not sure. I believe that's because they come from the like it comes out of JavaScript, where everything being null by default is just kind of what you're used to. So let's say that we have a type post that has an ID of, just make it an integer. Int. I said it's a while since I've been in this library, so I might have to look some stuff up. But that might be good for you guys to see as well. And then it might also have a number of comments. Or does it have like a comments? Let's just call it comments count. I'm not sure that we actually need the ID. No, we need like some sort of like deep relationship, right? Where we can actually like traverse the query deeply. And if we just had like number of comments, as soon as you like on the query trail, as soon as you say, have you loaded the number of comments, you can't go deeper than that because it's just an integer, right? The graph ends there. Whereas if we have a list of comments, you can then ask for what fields for each comment have you loaded. So that means we also need a comment, and that will just have a ID int. And so this should fail to compile, and it does. GraphQL scalar, GraphQL schema in the scope. Sometimes the compiler messages are a bit confusing. We forgot to say use super. So I'm expecting that it's going to complain about all this stuff down here that we just copy pasted. Yeah, so it says like coordinate is not in scope, and that this function is not a member of the query trait. So the way that juniper-from-schema works is that for each type, for each field, it generates a trait called the name of the type and then fields. And then in that trait, for each of the fields, it generates a function called field underscore and then the name of the field in snake case. So in this case, it's expecting us to define a field posts that returns a vec of posts, and it does not take any arguments. However, it does take a query trail that returns a post, or rather for a post, and walked. Oops. Vim's a little lacking here. So it also expects us to define a post struct which has a vec of comments. Comment. And then for that, let me just open a split here so we can look at the schema at the same time. Then it expects us to define post fields with a field comments method. Comment. And the comment returns a vec of comment. That should be it. And then we need to do the same thing for the comment. We'll just give it an ID of I32 and comment fields, field ID. And now the field ID, since this is like a leaf node in the graph, right? We don't get a query trail, which basically means that you can't go deeper into an int. You can't say what stuff does the int additionally load, because there is nothing. I think that should be it. So notice that we're just leaving all these unimplemented, which means that we basically don't care about it because it's not Juniper-from-schema's job to implement all this stuff. This is up to the user. So we just check that the functions and the type signatures that we generate are correct. And that's all we care about. So let's compile it again. Start from the top. So this is sort of a convoluted error message, but if we look in Juniper-from-schema's documentation, I'm not quite sure where that is. Yeah, customizing ownership. So in Rust, ownership is obviously a thing, but in GraphQL, it isn't really a thing. But if you just write a field like this, you don't necessarily know if this return value, if this is borrowed from self or from some other type. And it turns out that you actually need to be able to customize that, because in some cases it might be a borrow, or in some cases it might be an owned value. So by default, Juniper-from-schema returns or expects all functions to return references that live for the lifetime of self. And then if you need to return an owned value, you need to put this special comment, basically this special sort of doc string above your fields. So this is the complaint that it's getting us now. For example, here we say that we return an I32, but it expects us to return a borrowed I32. So we say this is owned, this is owned, this is owned. Let's see, the trait post fields is not implemented for post. Post fields post, comments field comment. And there we go. So now our test basically passes. Then what we're going to do is change, or sort of add an interface. Let's say that we add, let's imagine that we want to add an author here. So an author is a user to begin with. Int. We'll have to just implement that. User have an ID. User fields for user. And then we're up here in post, in the post trait, we have to also implement field author, which in this case returns a user. So what we can then do with this query trail is you can say stuff like trail dot what is it? I believe it's just author. Query trails. Right, no, the query trail is for a user, so we know that the user is loaded, but then we can ask if each of the fields of the user is loaded. So you can say trail ID, and that will then, so if we just look at the type, it says that this type is a bool. We just set it to nothing so that we can just see what type it actually is. So since ID is a scalar value or a leaf node in GraphQL, this method just tells us directly if the ID is loaded. But if we make our schema a little bit more complicated and we say that comments also have authors, then we just need to put this method on comment as well. And so now up here for the comment query trail, you're able to ask, so if we do the same thing again, trail, then you can say it's a comment. So then we ask it, is the author loaded? And then if the author is loaded, is the ID also loaded? And all these methods are generated at compile time. So then again, it gives us this bool, and then we can do stuff like when we actually were to implement this for real, we could say like if, then preload the ID or whatever. And if we look at just the type of the author, we can see that it just simply returns a query trail for a user, which is what we had before, the thing that we can call ID on, and then not walked. So on things that are not walked, this is all in documentation, by the way, if you think it's a little confusing, we can then like chain a bunch of these methods to look and sort of introspect the query. And then at the very end, we can say walk. And so walk will return an optional query trail for the user that is walked. So that means that you can do stuff like check if the user is there, and check if maybe the country is there, and I don't know if the country's planet is there or whatever. If you're doing like a game with multiple countries and multiple planets, whatever. It's a bit of a contrived example. So you can sort of chain all these like look ahead queries, and then at the very end, when you've constructed your whole query, you can say, okay, now check the whole thing at once. And then the way that you would actually use it is you would say if let sum walked trail, and then you can actually say like walk trail ID or whatever. So that's sort of how you use query trails. Let's leave this code for now, because it should keep working. I'm expecting that when we change this author or this user to be an interface, then this particular call is going to break. So for now, this should compile. And again, all this stuff is in the documentation. So if you're wondering how it works, or how you're sort of supposed to use it, it's in the documentation. So yeah, this works. Then let's say that we have an interface called entity, I don't know, that has an ID. And then we can say that this author field up here just returns an entity instead. We will have to update our code, so let's comment this out and just get it sort of back to compiling, right? So first thing, it says that there are no implementers of entity. So the way that interface is sort of the code that gets generated is that it generates, so if you have an enum called search result or entity in our case, it generates an enum that has a variant for each thing in our schema that implements that interface, so that we don't need to do any like we don't need to take our like concrete user type and then somehow like downcast it to something that just implements this trait. So we don't need to do any boxing or any trait objects or anything like that. It just uses an enum that has a variant for each that implements the interface. And then it also implements this from trait for each of the types. So you can just say search result from, and then this type, and then you don't have to worry about what the name of the actual variant is. However, since in our code over here, we didn't actually implement this entity interface for anything, it doesn't know how to generate the enum. So then it gives us an error. So then we say implements entity, compile again. So this time it says that the sort of query trail that we get, we expect a user. So this is on the post. Here we expect a user, but we actually get an entity. Yeah, and we're expected to also return an entity. And I suspect that it is the same down here. So this method is strictly not strictly necessary. So let's remove author from the post and instead only have it on the comment. Just because it's not necessary on the post, and then we don't have to like do the logic twice. So this method goes away, just so we're not confusing ourselves. Let's remove some code just sort of get the app back to a compiling state, right? Now we're back to working. Then we say that the comment, its author is just an entity. We don't know what it is. It might be a user. Let's look at what the compiler says. It says entity not found. That's because we deleted the interface. So it expected an entity but found a user in the query trail. That should be this one, entity. And it expects us to return an entity. And we need to do this ownership thing again. So there we go, now we're back to working. And now what the bug is, I believe, is that you cannot say trail.id. Even though we know that everything that implements this entity interface has an ID. As you can see, it complains. It says that there's no method ID for this type. So what I think we're going to do is just copy all this code to a different file, a different library, and then we can run cargo doc, and then we can see actually what code gets generated. So let's copy all this over. I've prepared like a little file here for it. Let's copy the schema into its own file. With this macro, sorry for jumping around here. Need the context. Oops. We had that already. Don't call this. Okay, so all I did basically was copy the code from before into another dummy library that I have myself, just so that I can sort of get a feel for how a user outside of my test suite would use the library. This is something that I've had great success with in the past. And so what that allows us to do is to run cargo doc and open the documentation, and then actually look at the methods for each of the query trail types that gets generated. So while that runs, let's see if we can expand this. So we need to implement both like these sort of leaf methods, or whatever you call it, on the so on the query trails, where the methods that return bool or int or string or something. And I would also like one that is a bit more complicated. So imagine like country. You can imagine that a user would have a country. So our documentation is ready now, and we can see that it has a query trail. And you can see that if we look for entity, you can see that it actually doesn't implement any methods at all. So for a query trail for a query, you can call posts, and for a query trail post, you can call comments, and for a user, you can say ID, comment, ID, author, so on. But there's actually no like impl whatever query trail entity. That thing is not there in the docs. But let's, as the very first thing, it still compiles. Let's add that country thing that I was talking about before. So let's say that all entities also have a country. Doesn't make a whole lot of sense, but why not? Countries also have IDs, which are just owned for the sake of the example. And then we have to do this boilerplate stuff for the country as well. We can actually just use the user, country. That should do it. Nope. Country, fields, and we have to implement field country on the user, and that's one of these that gets a query trail. Field country, query trail country. That works. So now I should be able to say trail ID, and I should be able to say trail country ID. There we go, that doesn't work, and this doesn't work either. Great. So what we will have to do, unfortunately, is copy all this code back. Maybe it was silly for me to copy it into a separate file. So from pub/struct query and below, so that's all this stuff, and also this, all the schema stuff. It should fail in the same way. Duplicate definition. Can I find that country in this scope? What did I copy over? Great, so now we get this same message got before. ID is not defined for this query trail, and country is not defined for this query trail. Sweet. What I will do, just so that we can actually watch our code compile along the way, I'll just comment this out so that we can actually compile. So now we get to the fun part. Basically, how Juniper from schema works is it has this function called parse and gen schema that takes the schema as it's read from a file, or as you can see in this case, like literally in the Rust code, and then it uses a crate called GraphQL parser, I believe, to just parse the GraphQL schema and then give us an AST that we can then walk over. And then it has a couple of passes through that AFT. The first one is it finds special scalar types like date and date time that it needs to define Rust types for. It does this pass I mentioned before where it finds out for each interface who implements that interface. Then it generates the query trail. This is the method that we're going to have to modify somehow. And then finally it generates the actual Juniper code. So let's say this query trails method is in the walk AST module, and that's just a re-export of gen query trails right here. So if you go ahead and open the documentation for GraphQL parser, it has it has two sort of things that it deals with. It deals with both parsing queries and parsing schemas. And the bit that we are mostly concerned with is parsing the schema. And then it just sort of has a whole bunch of different types. So usually what I do is I just look at the part schema function that takes some string representing a schema and then returns a document or some error. So the document is the schema, which contains a list of definitions, and these definitions are the type definition is mostly what we care about. So a type definition is either scalar, object, interface, union, enum, input object. These are like all the different types of things that you can have in GraphQL, sort of. So if we look at the gen query trails method, it does some stuff first that actually generates sort of the stuff for the query trail type that's always the same, regardless of what your schema looks like. So this is like the static stuff. And then it loops over each of these definitions in the schema, and then it matches on it. Currently it just says if it's a type definition, which is this one, and then if the thing inside that is an object, then we generate our walk methods. So currently we only handle this guy. What we also need to is handle this guy, and optionally, if possible, also this one. So let's start by converting this into a match so that we can actually match a few more. What is this node? This can be cleaned up when this is landed. Not sure what that is. Yeah, that's because we have to basically match twice. I guess I was wondering if you could like do that in just one line, but that's not going to work anymore because we need to first only match on one type, and then we need to match on multiple and actually pattern match and get the object inside the enum. So this is a match def object obj. No, this is the type def. That should do it. And it's complaining that our thing is not exhaustive. Rather, our match is not exhaustive. Let's just ignore all other cases than the one we actually care about. So code still compiles. Then we need to add a new case specifically for interfaces. And so an interface takes an interface type, interface. So currently gen field walk methods only work on object types. Object, it gets the name and the fields. That's basically all it does. I suppose we can do the same on the interface. Name and fields. I think that should work. Right. Let's first refactor this to not take a concrete object type, but take an enum that can then be either an object type or an interface type. We could also do it with making a trait and then implementing that trait for both object type and interface type, but I think just making an enum with two cases is much simpler. So let's do that first. What do we want to call it though? Any ideas in the chat? What should we call this? So it's a trait. It's an enum that is either a object type or an interface type. We could call it a method. A type. Type is just super generic. What the hell? That's a good name for it. Usually what I do in these cases is I just call it foo, and then I come up with a better name by the end of this. It's just so that we can actually make progress. So enum foo is either an object with an object type inside it, object type, or soon it'll be an interface with an interface type inside it. Not for now though. And then this is a foo object. And so since this object is actually a reference, because we're only borrowing the document in this method, I suspect that the compiler is going to complain that we need some lifetime here. Let's see when we get there. Expected reference. Expected. What's it saying? Expected reference. Enum query trails foo. Help consider borrowing. Ah. Yeah, so this is the error that I was talking about before. That it expects an own thing, but it got a borrowed thing. So that means that we have to add a lifetime. That should fix that. Except we need the lifetime here. That's that. So now we just need to implement name and fields. So what if we make name a method and fields a method? And implement name a self object type name. Name is just a string. Then we should be able to say match self object. Have to borrow it then? No. I'm not sure. Expected tick a string found type string. It does work. I'm wondering if it's going to complain that it wants us to return something that lives for tick A, but this particular borrow lives inside this scope and is not tied to inner. And therefore tick A might outlive this one. I'm not entirely sure. I'm not that experienced with Rust to know that. Usually the compiler just tells you what to do. So now we need to implement the fields method. Fields, which returns a vector field. Fields. It seems that we're back to compiling now. There we go. So apparently this is fine. So now I'm wondering, can you like leave these lifetimes off? Is that possible? Can the compiler infer that? It seems like it can. Awesome. Can you leave the lifetime off here entirely? No. Oh well. Halfway there. So now we should be able to do the same thing here and saying this is a foo interface for the interface. And, whoa. Jumps back and forth. And then add that. And handle each of them here. And we are back to compiling. So if that is all that we had to do, that would be amazing. Probably not. Let's see. That seems to work. And that does not work. Great, so it's not that easy. No method named country. Why is that? Trail country. So typically what I do in this case is like I need to know what exactly are the fields that we get out of our object, which means I'm going to be adding like lots of print statements in here. And since these print statements run at compile time, they will print for each other test that we have. So I'm just going to comment all the other tests that we have so that we can focus on running just this one. And then we can say here might be able to print the field. Like for example, if you say panic field, then it complains that we're not using the variable because I have deny unused imports, dead code unused variables. Let's turn that off for now. Actually, let's just allow it in this module. So this is the procedural macro panic. This is the panic that we added before, and it says field, which is the method that we put panic, which is the method we put here. So if we print the field, now we should be able to see exactly what the names of each field is. The field has a whole bunch of stuff. It does have a name though. Let's print that out. Country is there. It does seem like it is generating a country field method. So this is the case where I would like to actually look at the compiled documentation again. So we're going to do that thing that we did before, where we copy all the code back, paste it in. I'll copy over the schema as well. Whoops. So this should fail. Okay, this is a bit annoying. We needed to basically use our local, our local version of the code. And these things that didn't compile before. So how do you do that? Whoops, wrong repository. So in the cargo toml, you can say path, and then give it a path to the directory that then contains the other cargo toml. That should be this one. Now it should compile. If we then remove these, the ID did work, right? And the country did not. Right. Let's look at the docs. And maybe we can spot some pattern here. Query trail, entity, Yeah, for whatever reason, we're only implementing the ID. That is interesting. Why are we doing that? More debugging. Let's print out the name. And let's also print out the name of the field. This is a bit hard to see. Print out a couple of new lines in between so we can actually see where the debug output for each field sort of is. And then it is entity only gives us ID. Why are all the spaces here? Okay, so for the query, it has post, comments, entity only has ID, user has country. Oh my god, we didn't even add the country here. Has anybody in the chat seen that? Come on. That's embarrassing. Now it works, of course. Fantastic. Still compiles, so let's remove these. And just to be sure, let's run all the tests, including the doc tests. Very nice. Now we just need to come up with a name for this guy. Like my best idea is like method field source, or like thing with fields or something like that. Query, it could also be like query trail. Query trail root, query trail internal node, query trail node. That, I guess that makes sense. Query trail node, internal query trail node. It's a really long name. All right. So that is that. Let's commit it. See what we did. And we uncommented all the previous tests. Let's just bring those back. It still compiles. That was basically a very small change, right? Generate query trail methods for interfaces. Let's push it to CI and see if the test passed on CI. So what I'm wondering for union types. Since like a union type in so the way the union types work in Juniper is basically exactly the same as an interface. So like if you say you have a character like Rust enum that's either a human or a droid, and then you have some like characters or a character union in your GraphQL, then it basically handles sort of the downcasting for you. And then when you actually write your query, you specify each type that you actually want, and then the specific fields that you want for that type. Sorry if I'm rambling a bit here. So in this case, this is the example that they provide on the official GraphQL website, is you can have a union that's like a search result, and so when you search you can either get back a human, a droid, or a starship, and you can be like, if you get a human, I would like these fields, for droid I'd like these fields, and so on. And notice that the fields are different, and the data that you get back is also different. However, the enum that we have on the Rust side is an enum like this, and we cannot implement different methods for each variant of the enum because we don't know which variant it'll be until we have the query at runtime. So I'm not sure how. I don't think that we can solve that. Is it some more clear what the problem is? Anybody in the chat with any questions? Otherwise, no, I don't see how to do it. Because like, if we had a query like this, query, if I could spell, we could do it for all the fields that they have in common, but we're not guaranteed that they will have any fields in common. That's just really annoying. That means that if you need to do like eager loading of any kind, you can't use union types. I think we have to say that like that's a thing that we don't support. How does Juniper deal with it? What do they do if in this case, if I have a look ahead for the search query and I ask if we're querying for the primary function, I suppose it would say yes. Is what we have to do is make query trail methods for all the possible fields. That makes sense, right? But then you don't know where Like the name, this name might come in multiple places. It might not be here. Only on the human. So does that mean that if it is here, then it means that we are querying for the name? You just don't know specifically which variant that we're asking for the name on. I'm curious to explore the GraphQL's, like the Juniper side, and see how that actually handles it. I think we're gonna have to do that. First, I'll just open Travis CI. I haven't opened it in a while, apparently. Oh. Travis CI, just to see that our tests from before are actually working. Where'd the repo go? Maybe I never set up Travis CI for this repo. Let's make a note of that. Set up Travis CI. I think I will try to implement this example that they give here, and then actually sort of inspect how it behaves, and then figure out what we're going to do from there. So we're back in this sample project that we had from before. I've already included Juniper because juniper-from-schema depends on it. But we don't need this stuff. Do we need the context? They have like a quick start kind of thing. That's pretty nice. That also shows you how to run a query. And this, let's see if it works. It does if we run it. It's not a binary. Is the only difference in Rust between a library and a binary whether it has a librs or main rs? I guess we'll find out. So while we wait on that, let's look at the code that we just copied in. Favorite episode. Yeah, so that works. Let's just print it here instead. New Hope. Don't need these comments, they're basically just noise. So what we want to do is add, like extend this with something like this, right? Human droid. And then we can say that the episode But we forgot something. We forgot the most important bit. Cannot infer type. Type annotations needed. What? Maybe this example is out of date. This is the downside to using macros, that sometimes you get an error like this and you have no idea where that comes from. So I'm hoping that they have a working example in their docs. Otherwise, it's going to be annoying. Documentation. What is a GraphQL union? See description of GraphQL object. Syntax, GraphQL interface. Instance resolvers. GraphQL Union supports only description and interface resolvers items. No fields or interfaces can be declared. So let's copy over this guy and see if we can get that working. I don't think we need the lifetime. No fields. Expect nothing found. CTX. Why though? And this is supposed to be GraphQL Union. Primitive cast. Option droid. I don't know how to fix this. It would seem their docs are out of date, but I'm not sure. But now we're basically back at what we had before, right? This is the exact same thing. Yeah. Type annotation is needed. Cannot infer a type. What the hell? So now I'm wondering, like, what code do we generate over here in juniper-from-schema? How does that even work? GraphQL union. It does this. So it puts the context here. We're also not implementing, like, I know there is this, like, there's this trait. Why aren't we implementing that? And then the code that we generate, we disregard whatever is in there, throw that away, and it's still a borrow self. And then each instance resolver is like one of these bits. That looks very familiar to what we have over here. Yeah, that is exactly the same. Why the hell does that give us that error? I believe I have a working example in the juniper-from-schema docs. Union types here. So this is super annoying. Let's just copy all this code out so you don't lose it. Delete all of it. Well, almost all of it. Over in schema, paste in this. I'm basically trying to like recreate something that I know works. And this does not, which is because so there's a bunch of stuff that's like hidden in some of these docs that if I implement, or like if I included that everywhere, it would be a little bit repetitive. Which is this stuff. Whoops. Got a lot of Rust format. So this works. Now what I'm going to do is I'm going to see what code does it actually expand into. So there's a tool called cargo expand that basically expands all your macros, so you can see what code actually gets generated. Once installed, the following command prints out the result of macro expansion, derive expansion applied to the current crate. Actually, I just remember now, one of the features of juniper-from-schema, I believe, is debug print fmt. I think I'm wondering if I added in some feature to like debug print the tokens if debugging enabled. Yeah, I added a feature called format debug output, which will then at compile time, when it's done generating all your code. This is in the juniper-from-schema crate. Once it's generated all the code, it will print it to stand it out so you can see it, and it will format the code using Rust format. If it doesn't, the code is totally unreadable. However, using Rust format directly from Rust is unfortunately requires that you're on the nightly version. And I don't want my crate to require that, so it's a feature that if you want to use it, you have to be on nightly. So let's do that. Let's make a Rust toolchain file, nightly, compile again. I'm afraid this is going to have to recompile everything. So what we're then able to do probably also mention this feature in the docs somewhere. Is it in the README though? It's not. Mention feature for so then it compiles, and then what I believe we can do is build it again. Why? Maybe that's because from Vim I build with dash as tests, and from the command line I don't. It's kind of weird though. There's like, it could only use half of the incremental compilation assets. Main function not found in this crate. And then I should be able to say, after I add this feature, features, hopefully it doesn't have to rebuild the whole thing. God damn it. But it seems to be working because there's a bunch more dependencies now, which means that we're bundling in Rust format and then all of its dependencies. And I also bring in I believe I also bring in some library for actually formatting the code. I guess not. I think I looked into like some library that would like pretty print it and colorize it and stuff like that. So my original idea with this feature was that I would base the documentation on this, so that I would show, like in the docs, I would show like some snippet of what it was like to use the library, and then below I would show like the cargo expanded version. However, it turns out that cargo format does not format macros very well. So like all this stuff inside here, you're gonna see that very soon. It's like all smashed onto one line, so it's basically impossible to read. Which meant that I unfortunately couldn't use it for the docs. Oh well. But it's in the right file now. That seems to have worked. What? It didn't do anything. Why not? Is that because we have to cargo clean? And then rebuild for what, like the 5th time? If this doesn't work, I'm just going to run cargo expand on it. But no. like cargo, like what we're interested in is seeing which like Juniper macro calls are generated. Cargo expand will fully expand all macros, including the Juniper macros, which we don't want to expand because we actually want to see what happens. So that is not an option, unfortunately. I guess we will have to mess around with like just print the code directly without Rust formatting it, and then we can somehow copy it into Vim and then Rust format it from there. Rust C AP syntax. No, it doesn't print the code. Oh, there it is. So as you can see, like this stuff is Rust formatted, right? But all this stuff down here, all this nasty stuff, is not. Unfortunately, that is the code we care about. Union. GraphQL union. Whoops. It's not too bad, right? You can sort of piece it together. This feature where you can like hit % in Vim to jump to the matching brace is really quite useful. Tweet. Why did that not work? It's because we forgot the semicolon. This is why we saved all our previous code, because now we can just bring it back. And after yet another compile, it should give us the same error that we had before, even though we're on nightly now. Let's just clean this up a bit more. What we're gonna have to do is basically adapt this for our exact names and stuff. Match. Yeah, it's the same error as before. We don't need to clean both lines, I guess. So this is one of those cases where I'm always wondering if there's someone in chat who saw the bug a long time ago and just been screaming into their screen. No, the semicolon is there. What the hell? Match. Human. Character. Droid. Did that work? Context not found. Search result. Getting there. Same bug. What is this? Why does one thing work and the other one does not? That is the weirdest thing. I guess what we're gonna have to do is take this example with the union and then reproduce that and see if that works, and then sort of adapt it from there. You guys really get to see me do a lot of debugging. Context. Query empty mutation. I've experienced in the past that you can run into issues if you have an empty mutation. Let's just try it for now. Query GraphQL object. And like all this stuff we don't really care about. So the query has a search field that gets a string and returns a list of search result. Search result. A vec, which is then a union, and then we have an article and a tweet. So struct article ID string text. That, and then we can derive GraphQL object for it. And then we have to make this search result enum search result is either a tweet with a tweet or an article with an article. How do unions work again? Search result. I'm wondering why it's an empty thing here. I want it to be context. This is driving me fucking mad. Acquired because the implementation GraphQL for option article. Why the fuck? If we downgrade to Juniper 10, does that change it? I know that Juniper 11 was released recently. Oh, fairly recently. 11, 10.0. Let's see if that makes a difference. Interresolvable is not implemented for vector result. No, that gives us the same error. Okay, then let's go back on 11. Cannot invert type. I'm just wondering what enum do we generate over here? Variance. Implementer's name. Yeah, it's the same. I was wondering if we were like making some like reference types or something like that over here. But we're not. Like this stuff is literally copied from the docs, right? I suppose we file an issue with Juniper saying that whatever is going on, it doesn't work. This does work, right? No, cannot invert type. Type annotations needed. Yeah, the only thing I see that we can really do is file an issue. Let's do that. Macro, procedural macros. Any chance for input union support? Is that a thing? Anyway. Unions example from book doesn't compile. Let's just be sure. Let's remove the juniper-from-schema dependency. Same thing. So, as I mentioned before, I would also expect that like this particular line here should be character colon context and not union. Just mention that. Yeah, let's post this and let's see what they say. And then, what can we do for the time being? We could, technically, if we wanted to, we could actually release the crate, a new version in the current state that just works for, that generates these 4 interface types. And then we can mention in the documentation that currently doesn't work for union types. I think that might be interesting, so that we don't end on a low note, basically. Let's close a whole bunch of these tabs. Juniper docs, GraphQL. And then let's open it, build the docs. Here we go, doc. Because in the docs we have a specific, like a section for union types. Union type. No, the union types currently don't work with query trails. Expect that to be fixed a future version. Meaning that it will not generate methods for each field in the union. Note that union types currently don't work with query trails, meaning that it will not generate methods for each field in the union. Expect that to be fixed in a future version. Let's update the docs. Looks good. We could technically just not generate the query trail at all if we know this is a union type. I think I'm gonna not do that, first of all, because I don't know how common union types are, so I don't know how many users are actually using this feature, and also I expect that it will be fixed, and meaning that when we bring it back and we actually need this, it would technically be a breaking change to bring it back if we removed it. So I'm gonna not do that. I will update. Whoops, make a new commit though. And update the change log, because we did actually manage to get this guy working. Added fixed query trail methods now generated for interface types. And then we can release that as 012. Nineteen 114. This format of doing change logs in this way I stole from Diesel, a ORM database library thing for Rust. I saw it in his change log. He probably stole it from somewhere else. I just really like this sort of like stuff that's sort of unreleased. And then basically what you do when you release a new version is you just copy all this stuff into whatever version and put a date on it. And then he also adds this link where you can compare this version to the previous version. See all the commits and see the diff and all that stuff. So let's just do that. 1.2, compare 1.1 to 1.2. Should be it. Let's check it out. Markup is just like a general markdown rendering thing. Fixed query trail methods now generated for interface types. Alright. And let's push that. run the tests one final time, and if they pass, then we'll make a release. And they do. Toml, the version is now 0.2. Then in the library, need to bump this as well in the README. I believe the README is actually generated with cargo README. Yeah, I have this README TPL. So cargo README is a thing, a crate that just sort of generates a README markdown file from your crate documentation, which is super nice. Union. And our note is there. Let's just verify that it looks good. You can't search. Union types. No, the union types currently don't work with query trails, meaning that it will not generate methods for each field in the union. Expect that to be fixed in a future version. Nice. What did we change? Oops. This is just the README. Regenerate README. I have some tests that will like check that the version numbers are set up correctly. There is a crate called version sync that has you like define a file called version numbers, and then it can check that this version specified here in your crate docs actually matches the version defined in your cargo toml, which like these two can easily get out of sync, and then your documentation on like the link to your crates documentation on crates.io will be broken if this version number is not correct, or it'll link to the wrong version of the docs, which would be annoying. So bump to version 0.12. Push that. Hop over to master, merge it, and let's just push it. And check that our docs on Google looks on GitHub rather looks nice. Union. They do. And then I use a command called cargo release, I believe it's called. Yeah, that basically will do like a bunch of stuff that you need to do when releasing a new version, like tag it with the current version number, push it to crates.io, do all these things. And I usually forget how to do it. Cargo release. I think you just run cargo release. Try run. Tag. Create the tag. start the next development version. Push. It looks good. So this is basically how I usually at least publish my crates, using cargo readme to generate the readme, and obviously just the regular cargo document to look at the compiled docs, and then cargo release to actually do all the release stuff. I have, for some of my other crates, I have made like my own homegrown release script, but this one is just much nicer. Juniper. Here, the new version should hopefully appear. Fingers crossed. And then we can also, over on GitHub, we can look here for the releases, tags, releases, 011. I'm just wondering if like you need to do anything specific here, or if it made the release. I don't think I'm in the practice of doing that for this repo, which I guess is fine. Readme looks good. Change log, we looked at that before. It looks good. This link does work. Yep. And crates.io is up to date. It's up to date here, down here. Let's see, and this is also up to date here. The documentation is also up to date here. Sweet. So yeah, I think we're gonna kill this stream here. This was basically one final thing I'll just do. I'll just mention here that we actually fixed half of the problem. Resolved. I fixed half the problem. 0.12 will generate methods for interfaces, but not for query trails. I ran into some issues with Juniper and union types. Once those have been resolved, I should be able to fix it for union types as well. Opened an issue. Very nice. That was basically it. I think that's it for today's stream. If there aren't any further questions, just put them in the chat now. Otherwise, you're welcome to, of course, follow me on Twitch if you want to be notified of future streams. My plan is to do these streams. Like every couple of weeks, or rather a couple of times a week, rather. So follow me. I always post it on Twitter. I usually also post on Instagram. But if you just follow me here on Twitch, you'll definitely be notified. So if there's no final questions, I think we'll call it a day. Thanks for watching, and I'll see you in the next stream. Bye.